Everyone, welcome to our analytical chemistry presentation. Today we will discuss a fascinating topic entitled Multidisciplinary Learning, Redox, Chemistry and the History of Pigments. This work was developed under the direction of our professor, Dr. Gloria Edith Guerrero Álvarez, and presented by Sarita Valentina Ordóñez España and Karen Sofía Martínez Londoño. We are students at the Technological University of Pereira, and this presentation is part of our academic work for May 2025. Table of contents. In this video, we will guide you through the following sections. 1. Abstract. A summary of the main idea and importance of the topic. 2. Introduction. An explanation of the background and relevance of this study. 3. Objective. What the sought to achieve by connecting redox chemistry with the history of pigments. 4. Methodology. How the project is carried out through theory and experimentation. 5. Results. Finding from the project. And 6. Conclusions. Key lessons and final reflections.
Abstract. The intersection of art and science provides a wide range of educational and collaborative projects. The use of historical artists' materials for chemistry teaching has received increasing attention. We prepare and use copper, acetate, verdigris for a series of interconnected laboratory activities applicable from high school chemistry to heritage conservation research. This process illustrates scientific concepts such as redox chemistry and connect science to real-life scenarios.
Introduction. Interdisciplinary classes combining art and science have proven successful in teaching complex scientific topics. Art conservation students must understand basic chemistry and physics, as well as characterization techniques. Practices involving rapidly degrade materials allow for the simulation of chemical phenomena observed in historical objects. The activities described can be adapted for high school to advanced university courses.
General objective apply fundamental concepts of a chemistry, especially redox reaction through the synthesis, characterization and degradation analysis of the historic pigment verdigris, integrating scientific and artistic knowledge in a multidisciplinary approach. Specific objectives. First, synthesize the verdigris pigment using simple chemical methods and analyze the physical and chemical properties based on composition and crystalline structure. Second, evaluate the effects of accelerated pigment degradation on an organic meat such as paper, relating visual changes to redox and acid hydrolysis process. Third, apply acquired knowledge of redox chemistry and conservation to interpret the interaction between historical and art material and their environments, promoting an interdisciplinary approach between art and science.
Methodology. To carry out this study, five main stages were developed. 1. Verdigris pigment synthesis. Two synthesis methods were used. Simple method, metallic copper suspended in acetic acid in a sealed container, simulating a historical residue. And multiple method, copper sulfate was transformed into copper hydroxide using ammonia and soda, and acetic acid was subsequently added to form crystalline copper acetate. 2. Artistic preparation. The students used the verdigris pigment to create work on filter paper. Concentrate aqueous solutions were used, and gum arabic was used as binder to simulate traditional watercolors. 3. Accelerate aging. The works were placed in a climate chamber at 60 degrees Celsius and 85% relative humidity for several days. This simulated the natural degradation that historical documents undergo. 4. Visual and chemical analysis. Changes such as paper browning and support fragility were observed, caused by pigment oxidation reactions and cellulose degradation. In advanced course, techniques such as FTIR spectroscopy were applied to study chemical transformation.
Results. The results obtained were significant both visually and conceptually. Formation of the verdigris pigment. In the simple method, a blue-green crystal forming of copper shed suspended in acetic acid. In the multiple method, more defined crystals were obtained, although some students accidentally formed ammonia-copper complex due to excess reagents. Pigment color and appearance. The pigment ranged from light blue to emerald green, depending on the purity and the process. With mixed with gum arabic, the color in the sieve to were a dark green. In some cases, the mixture changed to reduce due to the formation of copper 1 oxide. A byproduct of organic redox reaction, effects of accelerating agents, the pigment paper shower discolorating, browning, and retailing in contrast to the unpigmented papers. This changes are due to the oxidation of the cellulose and the oxidation of the degraded pigment. The deterioration observed in inside manuscript and maps with a successful simulated student reflection, students identified the relationship between chemical process and the deterioration of cultural materials. Spontaneous discussions about redox chemistry, complex formation, and organic degradation arose, enriching the learning process.
Conclusions. 1. Redox chemistry can be taught in an interdisciplinary manner. The use of verdigris pigments allowed students to apply chemical concepts such as redox reaction, metal complexes, and the degradation of organic compounds in a real world and visually engaging context. 2. The degradation of art materials is a complex chemical phenomenon. Isolated agents demonstrate how moisture, heat, and pigment components negatively affect paper and other media. This enforces the importance of preventive conservation and chemical knowledge in the field of art. 3. The experience was useful for diverse audiences, from high school students to university students training as art conservators. The activities were adaptable and effective, connecting science with the real world.